Welcome to this comprehensive technical session on cover to concrete. As civil and structural engineers, ensuring the correct concrete cover is fundamental, not only for corrosion resistance and fire protection, but also for ensuring long-term structural integrity, bond performance, and durability in aggressive exposure conditions. Let's explore its types, functions, code-specific values, site practices, and failure implications. Concrete cover is defined as the distance between the exposed surface of concrete and the nearest face of embedded reinforcement. There are three primary definitions. 1. Clear cover, as per IS 456, is the actual measured distance between the outer concrete face and the reinforcement. 2. Nominal cover, commonly used in design drawings, includes clear cover plus construction tolerance, usually plus 5 mm. 3. Effective cover, critical for flexural design, is the distance from the extreme compression fiber to the centroid of tensile reinforcement. This dimension is used in moment capacity calculations. The correct interpretation of these terms is essential for both design and site execution. Concrete cover serves several interdependent roles. It acts as a physical and chemical barrier against environmental agents such as CO2, O2, moisture, and chlorides, thereby delaying corrosion initiation of steel. It contributes to structural fire protection, where minimum cover depths are required to delay thermal transmission and maintain residual strength under fire exposure. Concrete cover serves several interdependent roles. It acts as a physical and chemical barrier against environmental agents such as CO2, O2, moisture, and chlorides, thereby delaying corrosion initiation of steel. It contributes to structural fire protection, where minimum cover depths are required to delay thermal transmission and maintain residual strength under fire exposure. It ensures sufficient bond development length and anchorage of rebars, critical for flexural and axial capacity. Adequate cover ensures long-term durability, especially under Class B2 or Class C exposures, preventing premature deterioration of reinforced concrete elements. Cover requirements differ across standards, but generally fall within common thresholds. According to AS 3600, for structures in A1 exposure conditions, mild indoor environments, slabs require a minimum of 20 mm, beams between 25-40 mm, and columns 40 mm. IS 456 maintains similar values, while ACI 318 may prescribe 50 mm or more for members exposed to weather or ground. Always refer to the exposure classification, fire resistance requirement, and structural type to determine the final cover. In AS 3600, exposure classes range from A1 to C. As exposure severity increases, so does the required nominal cover to reduce diffusion of aggressive agents. For instance, a beam in Class B2, representing high humidity with chlorides, may require 40 to 60 mm cover. For marine substructure elements or coastal foundations, values up to 75 mm may be mandated. Fire rating affects cover significantly, as 3600 mandates minimum covers for varying fire resistance levels. These values ensure that reinforcement does not exceed 500-600 degrees CC, above which steel begins to lose strength and stiffness rapidly. On-site cover control is critical. Always use non-corrosive cover blocks of appropriate thickness, aligned with design drawings. Blocks should be placed at 900 mm intervals along rebars. Use chairs and spacers for slabs and walls. Concrete pouring and vibration must not displace reinforcement. Proper tying and stable formwork are essential to maintain cover tolerance. Post-pour verification is done using rebar locators or cover meters such as profometer or ferroscan. These devices identify the rebar location and calculate concrete cover depth. According to AS 3600, a tolerance of plus 5 mm is typically allowed. Always include cover verification in your quality assurance documentation, especially for Class B2 or marine structures. Inadequate concrete cover is a leading cause of premature structural degradation. Reduced cover allows ingress of CO2 and chlorides, triggering steel corrosion. Rust expansion causes concrete spalling, exposing further steel, accelerating failure. This leads to a loss in section capacity, reduced bond strength, and significantly shorter service life, particularly in critical infrastructure. To ensure concrete cover compliance, always refer to code-specific tables and approved drawings. Increase cover where required by exposure conditions or fire rating. Use standardized spacers or cover blocks. Post-pour inspections must verify as-built cover. Record all checks as part of your project QA process. Proper cover design and execution are cost-effective methods to extend service life and avoid early structural distress. If you found this technical breakdown helpful, support the channel by subscribing and sharing. Let me know in the comments how cover issues are managed in your projects or regions. See you in the next video.